Question 1 then tells us that we've got a normal distribution with a mean of 20 and a standard deviation of 4, so it's a variance of 4 squared, and we're asked to find the probability x is bigger than 25. So I'm going to do this by standardising. So remember, when you standardise, z is equal to x minus mu over sigma. So the probability x is bigger than 25 is the same as the probability that z is bigger than 25 minus 20 divided by 4. So if we work this out, this is the probability that z is bigger than 1.25, and then we look this up in our calculator. So if you get your calculator and you go for menu and 7, our distributions menu, we want a normal distribution, cumulative one, so that's number 2. And my lower value, if I draw a little graph here, I've got 20 in the middle, and I've got 25 here, and I want to find this probability. In terms of z, this value here is equal to 0, and this value here is 1.25, the one I've just calculated. So if I'm going for my standard normal distribution, my lower value I want to be 1.25. My upper value needs to be something over here, and as long as it's more than about 4 or 5 standard deviations away from the mean, then we're fine. So I'm going to put 5 in there. I'm on the standard normal distribution, so sigma is equal to 1, and my mean is equal to 0. So this gives me a probability of 0.1056. You need to be writing down 4 decimal places here in your answers and in your working. Now there is another way to do this, and you can do it without standardizing. So if we go back to the normal cumulative distribution, I'm going to put my lower value in as 25. I'm going to put my upper value in as something that's more than about 5 standard deviations from 20, so something like 100 is plenty big enough. Then my value for sigma is 4, because I'm not standardizing, I'm just going straight from this normal distribution I'm given. And my mu in this case is 20, and if I press equals, it gives me exactly the same answer without doing any of the standardizing. Now you need to know both methods here. If there's only 1 mark for the question, then I would do it on the calculator. If they ask you to show all your reasoning, then you need to know the standardizing method as well. Part B is telling us that the probability of a value lying between 20 and d is 0.4641, and is asking us to find the value of, the value of d. So I'll do this first using standardizing, and then I'll do it without standardizing and show you how to do it on the calculator. So what we need to do is find the z value that corresponds to the probability on this line here. So if this is 0.4641, the mean is halfway, so this probability in this area down here is going to be 0.5. So my total probability up to this point is going to be 0.9641. And I need to put that into my calculator to find my z value. So what I want this time is my inverse normal. So that's number 3. And my area is 0.9641. In this, I missed the point. No, I didn't. In this one here, what you do is you always put in areas to the left. Yeah, so the total area to the left. Because I'm standardizing, my sigma is 1 and my mean is nothing. And this gives me a z value of 1.800. So my z value here is 1.80. And then I use z equals x minus mu over sigma. So 1.80 is equal to d minus 20 divided by 4. So d is going to be 1.8 times 4 plus 20. And 1.8 times 4 plus 20 comes out to be 27.2. So if you're going to do this without standardizing, then go back to your menu again, number 3 for an inverse normal. You're still going to put in 0.9641 because that's your area, but this, oops, didn't mean to do that, bear with me. So 0.9641, as I say, is still your area. When you come down to your standard deviation though, that's now 4, and your mean was 20, so this gives you 27.2, so exactly the same answer. Just beware that if you get something wrong here, you get no marks, whereas if you put a bit of method down, you could pick up some method marks if there are any, but both methods are fine.